So this is problem 3.2 out of Griffith's Introduction to Quantum Mechanics. And before I start this problem, if you wouldn't mind, sorry, that's actually my dog moving my iPad because he's laying here and his paw touched it. If you guys would like more videos like this, please like and subscribe and I'll do more of that. So the question is, for what range of v is the function f of x equals x to the v in Hilbert space on the interval 0 to 1? We can assume v is real. So for it to be in Hilbert space, this inner product has to be finite. Okay? So this inner product then is x to the v times x to the v dx from 0 to 1, or the integral from 0 to 1 x to the 2v dx, which is pretty easy to integrate. You'll get 1 over 2v plus 1 x to the 2v plus 1 evaluated from 0 to 1. So just a simple power rule with integration. So now we can plug in, so we'll have 1 over 2v plus 1 times 1 to the 2v plus 1 minus 0 to the 2v plus 1. Okay. So now this part is obviously going to be just 1. So I'll just write it like this. And what we're looking for, if we look at this term, the power 2v plus 1, we want to make sure that that is greater than 0. If it's less than 0, then this number here will be negative and we'll have a 1 over 0, which is not what we want because that'll diverge. So that's why this is our inequality, and from here we can see v has to be greater than negative 1/2. Okay? And if we look for the specific case, so I guess starts part B, v equals 1/2, then the inner product, which we said was the integral from 0 to 1 x to the 2v, but now v is, well, minus 1/2, that's from our inequality. If we plug that in for our v here, then this is the integral from 0 to 1 x to the minus 1 dx, and the integral of 1 over x is just the natural log of x evaluated from 0 to 1. So this is the natural log of 1 minus the natural log of 0. The natural log of 1 is 0, and the natural log of 0, well, that has an asymptotic behavior, so that blows up to infinity. So evidently v cannot be 1/2, so it's a strict inequality. So we see that that is a problem. Now for v equals positive 1/2, well, obviously that is greater than minus 1/2, which is our requirement that we found over here. So clearly that is in Hilbert space. Now as for the function f of x, well, that would be x times x to the 2v, which is x to the 2v plus 1, and v we said is, what would they say, 1/2? Yeah. So this would just be, oops, x to the second power. And in that case, again, that works. And then the next part is the derivative with respect to x of f of x. So if, again, f of x is x to the 1/2, and we take the derivative of that, f prime of x is going to be 1/2 x to the minus 1/2. And in this case, we have a v which is equal to minus 1/2, and we know for a fact that that doesn't work. So if you have a function f of x which is in Hilbert space, there's operations and stuff that you can do to this function which takes it out of Hilbert space. So that's how you do this problem. Hopefully that makes sense, and if it does, please like and subscribe.